an opt meta directory, it knows that it should actually create opt meta in wherever the image is, the image directory is. But you can also use mcode here if you want. And then I simply move stuff from lib to mesa and from include to mesa. And that's the structure I want in my image, and Portage will handle the rest. It's as simple as that. So all these .configure make packages you want to install, it's really, really easy to put them into an e-build, and then for free getting dependency handling and uninstall ability. Now, after that, we use the e-build tool. Basically, actually, Portage is kind of a tool-level thing. Portage is more like the high-level dependency calculator thing, and whenever it actually executes something for a state from an e-build, it runs the e-build tool with an e-build. But you don't have to worry about that. Just know that you can run individual stages with the e-build tool. So in this case, I simply just specify the full path to my e-build and ask it to make it digest. And then I try to, just for testing purposes, running each of the stages, unpack, compile, install. And when I see that that actually works, I don't have to really test merge because that works. But then I want to see it actually works with dependencies and all. I try to run it from the emerge command, and it works nicely, and then I install it again. And that's it. That's my package.
Except for the digest step, the other e-build commands are, he's just doing them optionally. You could just jump straight to the emerge and it would suck and do the stages.
But on that note, I have found that usually whenever you think that you're lucky enough to have gotten it right the first time, you end up spending too much time debugging it. So test them individually anyway. It doesn't take that much longer. Okay, let's see another example. More interesting about this is a piece of software called Robius. It's a binary piece of software for controlling some small robots that we have in a lab in the computer science department at Copenhagen University, and it comes as an RPM package. How to deal with that? Well, this page there's nothing really new. I specify. Now it comes as an RPM package called toolchain. This is actually a cross compiler, and then some library that comes as a zip file. Most of this you will already know, license, slot, whatever. In this case, I depend on, I need RPM to target zip for handling the RPM package, and unzip for unzipping this file. But they are own dependencies. I also specify R dependencies to have nothing. Once I installed it, I don't really need these tools anymore. If I hadn't specified R depend, they would just be the same as depend. And in this case, I again override S, but this is more specifically because I know that these two packages put the software in a other kind of structure than the usual.
You have the default there, don't you?
No, usually that's the version also.
No, P is the package plus version. P
Oh, sorry,
is
yeah.
just the name.
Yeah, sorry, yeah. Then it's the default one. Then it's redundant. Okay, unpack. In this case, I want to override the unpack stage because I need to unpack the RPM and I need to do something else. I go to the work directory. I basically unzip the zip file and create a tar file from the RPM package. Notice that I don't unpack the tar file here. I will come back to why I don't do that later. But then, it's a binary distribution, so I don't really have anything to do in compile. So I just stuck a nice little note for the user to look at, and don't really do anything else. And then, in the install phase, I choose to unpack the tar file that I created before. Now, this shows two things. First of all, I did this because this has to run on a fairly stupid file system, with a fairly stupid file system, so unpacking to one place and then in a second later moving it to another location is quite redundant, so I just unpack it directly into the image directory. The second thing it shows is that even though that we have these stages called unpack, compile, install, you can really do whatever you want in them, just that it makes sense. I don't have to unpack everything in the unpack stage, I can do it here.
I have a little question. It looks like a shell function. Its syntax is
Bash.
shell? Bash?
Bash.
Bash. I see.
And whatever you can do in Bash, you can do here.
Oh. It's quite good.
So, for people who don't know much about scripting, usually say, well, think about an eagle as an how-to list for how to install a piece of software that you can actually execute. Because that's what it is. I create some directories, move some things around, set some modes, and that's about it. Then I have here two environment variables that I put into a special structure, but I won't come into that because that is strictly Gentoo Linux specific. You can read about that somewhere else. But basically a script, like anything.
That's quite good.
People started realizing how much they miss by using other distributions.
Now, E-classes, I won't really explain E-classes because it's quite a big topic, but the main idea in E-classes is that when you create many e-builds, specifically you create one or more revisions for every new version of software, usually you end up doing some things over and over and over again, so you want to reuse code. This is where E-classes come in. E-classes are basically stuff you can import into your own e-build and use. But it's a little more advanced than that. An e-build can just contain additional functions or even additional variables if you like it, but it also implements something that mostly resembles C virtual functions. Basically it means that it can override the default behavior of stages, and unless you re-override them in your e-build, they will be executed instead of the Portage default ones. So, and this is an example, this is actually an official package. Now I want to show exactly how powerful that can be. Whatever happens here is not really important. This is a source file, and basically the Gentoo sources software is basically the official kernel source with some patch set.
Lots of patches.
Lots of patches. So installing this piece of software involves getting the official kernel source, getting all the patches, finding out what patches you need, do a hell of a patch job, and doing it in the right order, and then you have your source and install it. And it can be, if you did this manually in every package, I think it could be tedious. But instead they have made an e-build, they inherit kernel 2. And then they have, you should recognize that, but you also have some variables up here. These are not official Portage variables, these are variables used by the E-class. And you have to read the E-class to understand what they do. So it's just to show that you can use your own variables too.